So section 5.3, operations on rational expressions. To better understand how to simplify rational expressions, we start by reviewing how to simplify numerical fractions. So do you want to think about the rules for simplifying fractions? If the numerator and denominator have a common factor, we cancel out the common factor. So you can do that by dividing it out or factoring your numerator and denominator and canceling out the common term. So for instance, 6/8, that's 6 is 2 times 3, 8 is 2 times 4. Both the numerator and denominator have a 2. So we can cancel out that 2. And this just simplifies to 3/4. Okay. Similarly, rational expressions are a polynomial divided by a polynomial. If we can factor our numerator and factor our denominator, and there is a common factor in our numerator and denominator, we can cancel it out just like we canceled out the 2's above. And that will help us simplify rational expressions. Okay, because with rational expressions, our numerators are polynomials, we have to use the techniques that we learned for about factoring back in chapter 4, to factor by pulling out your greatest common factor, factoring into trinomials into 2 binomials, and then the difference of squares. We're going to use all of those techniques to factor our numerator and denominator as much as possible, and then cancel out any common factors in the numerator and denominator. So this section will rely heavily on being able to factor. And just as a quick note, if you remember back in chapter 4, we also needed to know how to factor to solve quadratic equations that involve factoring. So this pops up a lot in chapters 4 and 5. Knowing how to factor is very, very important for several of the types of problems that we'll need to solve. So make sure you practice that if you have not already. I'm going to skip the worked example and just go straight to our practice problems, the U-tries. So we'll start with problem 3. What we want to do in all of these problems is factor the numerators and denominators as much as possible, and then cancel out any common factors. I usually do this. Well, problem A, this is kind of similar to some problems we saw back in chapter 2. I want to do purple today. Well, let's do this. So for our numerator, we have the number 12. 12 can be factored to 3 times 4. And then x squared is x times x. So we can write this as 3 times 4 times x times x. And then in our denominator, we have 16x. 16 is 4 times 4, and then times another x. Then you want to see what factors you have in common in the numerator and denominator and cancel them out in pairs. So one of the 4's in the numerator, or the 1 4 in the numerator can cancel with one of the 4's in the denominator. One of the x's in the numerator can cancel out with the 1x in the denominator. And then what are we left with? In the numerator, we're left with 3x, and in the denominator, we're left with 4. So the expression 12x squared over 16x simplifies to 3x over 4. All right. I always like to show the problem using factoring like this. Some students or some other professors also show their work slightly differently. So of course, we'll get the same exact answer. We're doing the same thing as far as canceling out a 4 and canceling out an x, but there's another way you can show your work. And if you are used to showing your work this way, you can write it either way. So with 12x squared over 16x, sometimes people will look at the numerical factors, 12 and 16, and you think to yourself, what's the biggest number that divides 12 and divides 16? That would be 4. So you divide it. 12 divided by 4 is 3. 16 divided by 4 is 4. Or you just think about simplifying 12 over 16. That's 3 over 4. And then for the x's, you know, if you have an x squared over an x, this x cancels and the squared cancels there. So some people like to show their work this way. That is fine also. It may look a little bit messier for some people. So only do it if you like it that way. I prefer to write things out in factored form because it's a little clearer to see what's canceling out. But either of those are appropriate ways to write your work. All right, then on to B. In part B, our numerator is 2x minus 3. That actually cannot be factored anymore because we can't pull out a common factor from either of those terms. There's nothing to factor. It stays the same, 2x minus 3. But in our denominator, 10x minus 15, we can factor out a 5 from 10x and a 5 from 15. So this would be 5 times 2x minus 3. Then notice here, I have to point this out explicitly, just to remind you guys, factors are things that are being multiplied. So in the numerator, 2x minus 3, that's all together one factor, okay? And we can cancel it out with the 2x minus 3 that's being multiplied by 5 in our denominator. Then what are we left with? The entire numerator cancels out, so we're left with a factor of 1, not 0, 1. And in the denominator, we're left with a 5. So this expression simplifies to 1/5. All right. I'm going to keep rolling through these. Remember, we're factoring the numerator and denominator as much as possible and then canceling out any common factors. For part C, 3x plus 9 over x squared minus x minus 12. In the numerator, we can factor out a 3. So we'll have 3 times x plus 3. And in our denominator, that trinomial can be factored to x minus 4 times x plus 3. All right, then we see that both our numerator and denominator have a factor of x plus 3 that we can cancel out. Then what does that leave us with? We have a 3 in our numerator and x minus 4 in our denominator. That's our final answer. All right, last one from this section, x squared minus 4 over x squared minus 2x. In the numerator, x squared minus 4, that is a difference of squares. So this factors to x minus 2 times x plus 2. And in our denominator, x squared minus 2x, it's not a difference of squares, but we can factor out an x. We can factor out an x from both of those terms. So this would be x times x minus 2. All right, then we can factor out the x minus 2's, and we're left with x plus 2 in our numerator and x in our denominator. All right, someone may be sitting there thinking, well, can we cancel out the x's there? The answer is no, no, no. You can also only cancel things that are being multiplied. So like, if you look at the step before, x minus 2 is one factor, that's all together, the x minus 2. X plus 2 is one factor, it's all together. Okay, we can't just cancel out the x and leave the 2 there. So this is the end. We can't simplify this any further. For part A, in the numerator, we can factor out a 2. So this is 2 times x minus 2. And in a denominator, this trinomial factors to x minus 2 times x plus 1. So the x minus 2's cancel out. Sorry, I want to cancel them with a different color. And we're just left with 2 in the numerator and x plus 1 in the denominator. So that's good for part A. For part B, x squared minus 9 over x squared minus 3x. This would be x minus 3 times x plus 3 in the numerator. That's a difference of squares. And in the denominator, we can factor out an x. So that's x times x minus 3. The x minus 3's then cancel out. And we're left with x plus 3 over x. Then, now that we know how to simplify rational expressions, we're going to move on to talking about doing our operations, multiplication, division, addition, and subtraction for rational expressions. Again, a rational expression is just a fraction. So you're going to multiply rational expressions the same way that you would multiply fractions. P over Q times R over S is equal to P times R, multiply the numerators together, over Q times S, multiply the denominators together. We also want our answer to be in simplified form. So let's think about if we had something like 2 over 5 times, I don't know, 15 over 4. If you wanted to just multiply these numbers, some of you may say, oh, 2 times 15 is 30, 5 times 4 is 20, and then simplify this, divide by 10, this is 3 over 2. Okay, that's one way to simplify. Another way is to try to simplify before you multiply. So you'll look at your numerators and compare them to your denominators. Do either of the numerators share a common factor with either of the denominators? For instance, 2 and 4 are both divisible by 2. So we can say 2 divided by 2 is 1, and 4 divided by 2 is 2. 5 and 15 are both divisible by 5. 5 divided by 5 is 1, and 15 divided by 5 is 3. Then if we simplify before, once we do our multiplication, we get an answer that's in simplified form. 1 times 3 is 3, 1 times 2 is 2. These are the two different ways we learn to multiply and simplify. Either multiply first and then simplify, or simplify first and then multiply. When we are dealing with rational expressions, it's definitely better and easier and more doable if we try to simplify first. So we're going to use this second method. We're going to try to factor our numerators and denominators as much as possible. If there are common factors, we're going to cancel them out and then multiply what's left. And we'll have our final answer in simplified form. All right, let's do that. Okay, I want to skip through the examples that are already worked for us and go straight to the try it problems. Ooh, look at all this fun. All right, how many do we have here? Good, a good number. 1, 2, 3, 4, 5, 6 problems that we get to do here. All right, we want to try to factor each numerator and denominator as much as possible. And then when we're multiplying, you can cancel out anything in either numerator with anything in either denominator, okay? For part A, 55 55x cubed over 15y to the fourth times 16y cubed over 3x squared. If we factor the 55x cubed, that would be 5 times 11 times x times x times x over 15y to the fourth, that's 3 times 5 times y times y times y times y. All right, then 16y to the fourth, 16 is 4 times 4, or you can write it as 2 times 2 times 2 times 2, whichever one you want. 4 times 4 times y times y times y, and then 3x squared is 3 times x times x. I want to point out again, you do not have to write it out in this form if you prefer to just like say, oh, 15 is divisible by 5 and 55 is divisible by 5. That's 11 and 3. Some people learn to simplify this way and prefer that method. That's fine. I just like to show it this way because it's easy to visualize what we're canceling out. You can also just use our properties of exponents to say, oh, we have an x cubed and divided by an x squared. That's just going to leave us with an x in the numerator. That's fine too. But using this method of writing everything out just makes it a little clearer to see what cancels. All right, now my favorite part, canceling stuff. We can only cancel a term in the numerator with a term in the denominator. It can be either of the denominators or either of the numerators, but you can't cancel numerator and denominator and denominator. So what cancels? I can simplify by canceling out a 5. I can cancel out 2 of the x's in the first numerator with the 2 x's in the second denominator. I can also cancel out 3 of the y's in the first numerator. I'm sorry, the second numerator with 3 of the y's in the first denominator. Am I missing anything? Does anything else cancel out? No, I don't think so. So then we multiply what's left. Sometimes it's hard to see what's left. You may want to circle. We have an 11, an X, a 4, and a 4. Then we have a 3 in the denominator, a Y, and another 3. All right, so let's multiply this. 11 times 4 times 4, that's 11 times 16, which is 176, times X is what's left in the numerator. And in our denominator, we're left with 3 times Y, so 9Y. And that's our final answer. Okay, so factor each numerator and denominator as much as possible. Cancel out any common factors in the numerators and denominators. And then when you multiply what's left, you'll have your answer in simplified form. Remember, we multiply the numerators and multiply the denominators. All right, on to part B. In part B, we want to try to factor our numerators. Our first numerator is just X, nothing to factor there. The first denominator is 3X plus 15. This factors to 3 times X plus 5. Okay, and then our second rational expression is actually already factored. X plus 5 over X minus 2. No more factoring can be done. Okay, so what common factors are in the numerators and denominators? The only common factor that we can cancel would be the X plus 5s. There's an X in the numerator, but there's no factor of just X by itself in a denominator. And then there's a 3 in a denominator, no 3 in the numerators. There's an X minus 2 in the other denominator, no X minus 2 in the other numerator. So that's it. That's all we can cancel out. And when we multiply, our numerator just has an X in it, and our denominator is 3 times X minus 2. So X over 3 times X minus 2 would be our final answer. For part C, Y squared minus 4 over 4Y times negative 2 over Y plus 2. We can factor that first numerator. It's a difference of squares. So that would be Y minus 2 times Y plus 2 over 4 times Y. And then times, let me go back a little bit here. We can also factor the 4. 4 is 2 times 2. So that's 2 times 2 times Y. And then times negative 2 over Y plus 2. All right, what things cancel here? First, we can definitely cancel out a Y plus 2 from the numerator and denominator. But also, we can simplify that negative 2 in the second numerator and one of the 2's in the denominator. Negative 2 divided by 2 leaves us with a negative 1. So that 2 cancels out. This 2 becomes or this negative 2 becomes a negative 1 if you divide both by 2. And is that it? That's all the stuff we can cancel. So what are we left with? In the numerator, we have Y minus 2 times a negative 1. So we'll just make that negative Y minus 2. And in our denominator, we're left with 2 times Y, 2Y. For that negative, where should you put it? You can put it with the numerator or you can put it just in the front. I usually like to write it just out front. So negative Y minus 2 over 2Y. And also you can keep the parentheses in your numerator if you'd like. But moving on to part D. 4P over P squared minus 3P minus 10 times 5P over 8 times P squared. All right, 4P is, you can write it as 2 times P if you want. P squared minus 3P minus 10. This factors to P minus 5. P minus 5 times P plus 2. For the second numerator, P minus 5 can't be factored anymore. And 8 is 2 times 2 times 2. 2 times 2 times 2. And then times P, P squared. Let's start by canceling out the 2's and P's that we can. We can cancel out 2 2's and 1 P. Then we can also cancel the p minus 5s. That leaves us with everything in the numerator cancels out. That gives us a factor of 1 in our numerator. And in our denominator, we have p times p plus 2. So our final answer is 1 over p times p plus 2. All right, just a quick little note. Oftentimes I have students ask me, like, for the final answer, should they keep that denominator, p times p plus 2, in factored form, or can they distribute and write it as p squared plus 2p? Either way is acceptable. You can stop here, or you can take it one step further and write it as 1 over p squared plus 2p if you want. All right, 2 more to go, and these are my favorites because they have so much factoring in them. All right, let's see. With part E, we look at our first fraction and our first numerator. N squared minus 7n factors to n times n minus 7. And our denominator, n squared plus 6n plus 9, that factors to n plus 3 times n plus 3, or n plus 3 squared. All right, our second numerator, I'm sorry, is just n plus 3. And our second denominator is 4n. You can factor it to 2 times n, but nothing's going to cancel, so I'll just leave it as 4n. All right. When I say nothing was going to cancel, I mean the 4 isn't going to cancel, so I can leave it as a 4. The n in the numerator cancels with the n in the denominator. And then the n plus 3 in our second numerator cancels with one of the n plus 3s in the first denominator. And I think that's all the canceling we can do. So we are left here with, in the numerator, n minus 7, and in our denominator, n plus 3 times 4. So I'm going to write that as 4 times n plus 3. All right. Woohoo, last one. Lots of stuff here to factor. Our first rational expression, the numerator, 2w squared minus 18w, we can factor out a 2w from both of those terms, and we'll be left with 2w times w minus 9. All right, in the denominator, we have 6, oh, yeah, that's right. We have 6w plus 30. We can factor out a 6 from both of those terms. So we'll have 6 times w plus 5. And then for our second numerator, w squared plus 7w plus 10. This is w plus 5 times w plus 2. And lastly, the w minus 9 can't be factored anymore. So we just have that as a w minus 9. All right, what can we cancel? We can cancel the w's, or w minus 9s, I'm sorry. We can cancel the w plus 5s. 2 and a 6 can simplify. 2 divided by 2 is 1, 6 divided by 2 is 3. So that simplifies to a 1/3. All right, now we've gotten everything. In our numerator, what's left? We have a w and a w plus 2. So w times w plus 2. And in our denominator, we're just left with this 3. That's it. So yeah, w times w plus 2 over 3. All right, 1 operation down, 3 to go. This is multiplying polynomials. We also have to talk about dividing, adding, and subtracting. For problem 7, 1 over y minus 6 times y squared plus 4y minus 12 over y plus 6. All right, this first term, or first expression, does not factor, so it stays the same. In the second one, the numerator factors to y plus 6 times y minus 2, and then over y plus 6. The only thing that cancels here are the y plus 6's. And then we'd be left with y minus 2 over y minus 6. Again, I'm going to emphasize this because it happens all the time. We cannot cancel the y's here because the y minus 2 is one term. They're stuck together, the y and the minus 2. And then same with y minus 6, that's one term. We can't just cancel the y's. We also can't just simplify the 2 over 6. Y minus 2 is one term, y minus 6 is one term. They're together, they can't be broken apart. All right, on to dividing rational expressions. Remember again, rational expressions are just fractions. So we divide rational expressions the same way that we divide fractions by doing keep, change, flip. Dividing by a fraction is the same as multiplying by its reciprocal. So for every division problem with rational expressions, we'll start by rewriting the problem as multiplication by taking the second expression and multiplying by its reciprocal. So if we have P over Q divided by R over S, that's P over Q times S over R. So notice that we change the division to multiplication, and we change R over S to its reciprocal, S over R. Okay, so to divide rational expressions, we multiply the first expression by the reciprocal of the second. And then from there, it works just like the previous multiplication problems we've done. Multiply the numerators, factor the numerators and denominators, cancel out the factors, and simplify. If you look at the steps, notice the only difference between multiplication steps and division steps is the first problem, the first step. Rewrite the division as a multiplication and then follow through with your multiplication steps. So before you do any factoring, before you do anything, rewrite the problem by multiplying by the reciprocal of the second expression. And then factor and simplify and multiply. All right, again, I'm gonna skip through the worked example and go straight to the you try it. We have 6 of these to try. And for all of them, I'm gonna start off the problem, not by factoring, but by rewriting it. So for 4x over 3x minus 9 divided by 12 over x minus 3, this is 4x over 3x minus 9. The first expression stays exactly the same. Times, change from division to multiplication. And then we want the reciprocal of the second expression. Ooh, what happened there? Instead of 12 over x minus 3, we get x minus 3 over 12. All right, once the problem is written this way, then we factor, cancel out common factors, and multiply what's left. All right, our numerator here is 4 times x. The denominator is 3 times x minus 3. Our second numerator is just x minus 3. And our second denominator, 12, can be factored into 4 times 3. Then we cancel stuff. The x minus 3's cancel, the 4's cancel, and then that's it. We can't cancel the 3's because both of them are in the denominator. So our final answer here would be x over 3 times 3, 9. That's it. So the problems work very similarly to the steps we do for multiplication. Once you do that first step, we change it to a multiplication problem by taking the reciprocal of the second fraction. Part B, x minus 6 over 2x minus 6 divided by x plus 3 over x squared minus 9. First, we rewrite this, keep the first fraction or the first expression the same, then multiply by the reciprocal of the second one. Now this is a multiplication problem. We factor, cancel, and multiply. X minus 6 is already factored. 2x minus 6 is 2 times x minus 3. X squared minus 9 is a difference of squares. X minus 3 times x plus 3. And x plus 3 is already factored. Then we cancel. We can cancel out an x minus 3, an x plus 3, and that's it. So in the numerator, we'll be left with x minus 6, and in our denominator, 2. And that's our final answer. Again, I'm going to point this out. These problems rely heavily on being able to factor. If you can't factor, then you won't be able to be successful on these types of problems at all. So if you're struggling with factoring, like I said, make sure you go back to, what did we learn at section 4.3, 4.4, and practice those, or actually 4.4, practice those factoring techniques. All right, on to part C. 4x squared plus 12x divided by 12x plus 6, 4x plus 12x over 12x plus 6 divided by 9x squared minus 9x over 6x plus 3. We rewrite this as multiplication. It's 4x squared plus 12x over 12x plus 6 times reciprocal of the second expression, 6x plus 3 over 9x squared minus 9x. And then we factor. The first numerator factors to, we can pull out a 4x from both terms. So that'll be 4x times x plus 3 over, we can pull out a 6 from the denominator, 6 times 2x plus 1. And then from the numerator, 6x plus 3, we can factor out a 3. 3 times 2x plus 1. And then from the second denominator, 9x squared minus 9. Ooh, this is going to factor a lot. We can factor out a 9x. And then that gives us, oh no, I thought it factored more. Just factor out a 9x. And we can factor, or that leaves us with an x minus 1. Yeah, that's it. Not as exciting as I was hoping. All right, then from here, what cancels? The 2x plus 1s cancel. The x's cancel. We have an x here and an x here. And then for the rest of these, you have to play around with the numerical factors. If you want, like if you feel like this looks kind of messy, you can go on to a next step where you just have the 4 times x plus 3 times 3 over 6 times 9. If you want, you can just write it that way and then simplify again. But I'm going to simplify from here. Let's see, we have 4 over 6. That becomes a 2 over 3. And then 3 over 9 becomes a 1 over 3. And I'm running out of space to the left, or to the right, sorry. Let's see, so this is in the numerator. We have a 2 times 3 plus x, or x plus 3. I don't know why I read that backwards. And then over 3 times 3, so 9, x minus 1. All right, that one had a lot of simplifying and a lot of simplifying numerical factors. All right, let's see. When we rewrite this one, we get x plus 9 over 2x minus 12. And then it's times x minus 6 over x squared minus 81. This gives us x plus 9 over 2 times x minus 6 times x minus 6, it's a weird looking 6, over x minus 9 times x plus 9. All right, then from here, the x minus 6's cancel, the x plus 9's cancel, and we're left with, which is I think what Robert gave, 1 over 2 times x minus 9. All right, part E, we have x squared plus 5x plus 6 over 6x plus 12 divided by x squared plus 2x minus 3 over 6x minus 6. If we rewrite this, we get x squared plus 5x plus 6 over 6x plus 12 times 6x minus 6 over x squared plus 2x minus 3. And then we factor. First numerator becomes x plus 2 times x plus 3. First denominator is 6 times x plus 2. Second numerator is 6 times x minus 1. And second denominator is x plus 3 times x minus 1. All right, then what cancels here? The x plus 2's cancel. The x plus 3's cancel. The x minus 1's cancel. Oh, this is so fun. My favorite part is canceling. The 6's cancel. So what happened? Everything canceled. What does it mean if everything cancels out? That means you get a 1 over a 1, or this just simplifies to 1. Then last one, F. All right, I don't see any answers coming through. When we rewrite this one, we get m squared minus n squared over 8m minus 8n times 24 over m minus n. All right, factoring. M squared minus n squared is a difference of squares. That would be m minus n. What is happening? M minus n times m plus n over 8 times m minus n, and then times 24, which is 3 times 8, over m minus n. Is that right? Yeah. All right, so we can cancel one of the m minus n's in the denominator, and we can cancel the 8's. And then that leaves us with 3m plus n divided by m minus n. And that's our final answer. All right, so now we know how to simplify rational expressions, multiply and divide. Next, we need to talk about adding and subtracting. To subtract fractions, you have to have common denominators. If you don't have common denominators, then you have to find the LCD, least common denominator, multiply, and make your denominators the same some kind of way, okay? For our problems, we're only going to be looking at, for the most part, pretty much only rational expressions that already have the same denominator. So not too bad. If you have expressions that have the same denominator, we can add or subtract them by adding or subtracting the numerators, and then you keep the common denominator. So your denominator stays exactly the same, and you just add or subtract the numerators based on whatever operation you're given. After adding or subtracting, we then want to try to factor and simplify if possible. Okay, so again, we have to have common denominators in order to add or subtract. For us, we'll only look at rational expressions with common denominators. Okay, before we jump into examples, we just want to point out what it means to have a negative in front of a fraction. Remember, having a negative fraction means either the numerator is the numerator is negative, or the denominator is negative. Okay, so you can apply the negative sign to either the numerator or the denominator, but not both. Okay, sometimes you may have to factor out a negative from an expression also to simplify. We'll see what these all look like. All right, problem 10's already done for us. So we're going to jump straight to the U-try problems. Again, notice all of these already have common denominators. So we don't have to worry about finding a common denominator, okay? Same with example 13, we already have common denominators. And then I think that's it, yeah. So we have 2 more groups of problems. We'll look at 11 and 13, and then I'll stop. For 11, we're gonna add or subtract our numerators, keep our common denominator. These are all adding, right? Oh, wait, these are all adding. So add our numerators, keep our common denominator, and then try to simplify after if possible. Part A, 5x plus 7, or 5x over 7 plus 9x over 7. This would be 5x plus 9x over 7, which is 14x over 7. Then you want to simplify. 14 divided by 7 is just 2. So this would simplify to 2x. So with multiplying and dividing, we factored first and then did the multiplication. With addition and subtraction, we'll add or subtract first and then simplify. Okay, so factor second. All right, for part B, x plus 4 over 6x minus 12 plus x minus 8 over 6x minus 12. This would be x plus 4 plus x minus 8 over 6x minus 12. This gives us 2x minus 4 over 6x minus 12. All right, from here, then you want to try to factor your numerator and denominator as much as possible, cancel out common factors, and simplify. Our numerator can factor to 2 times x minus 2, and our denominator factors to 6 times x minus 2. We see those x minus 2's cancel out, and that leaves us with 2 over 6. But 2 over 6 can be simplified more. That's just 1 over 3. On to part C, okay? If we add the numerators together in part C, 3x and 6, we get 3x plus 6 over our common denominator, 2x squared minus 4x minus 16. Again, we do not add the denominators together, we just keep the common denominator. Factoring here gives us 3 times x minus 2, or x plus 2, over 2x squared minus 4x minus 16. We can factor out a 2. And then we have x squared minus 2x minus 8, which can be factored more. Okay, so this is 3 times x plus 2 over 2 times x minus 4 times x plus 2. All right, now we can cancel the x plus 2's in the numerator and denominator. And that gives us a final answer, I have to write it below here, of 3 over 2 times x minus 4. All right, 2 more to go. Letter D, x squared minus x minus 5 plus 1 minus 2x. If we combine those numerators, we get x squared minus x minus 5 plus 1 minus 2x over x squared plus 3x plus 2. Simplifying the numerator gives us x squared minus 3x minus 4. And our denominator is still x squared plus 3x plus 2. Factoring the numerator and denominator gives us x minus 4 times x plus 1 over x plus 2 times x plus 1. The x plus 1's cancel. And we're left with x minus 4 over x plus 2 as our final answer. All right. Then last addition problem. 6x plus 8 minus 2x is our numerator. And our denominator stays the same, 4x squared minus 4x minus 24. All right. Our numerator simplifies to 4x plus 8. And in our denominator, we can definitely do a good amount of factoring there. We can factor out a 4. And we have x squared minus x minus 6. Yes. Okay. Then from here, let's finish up our factoring. The numerator is 4 times x plus 2. The denominator is 4 times x minus 6 can factor to x minus 3 times x plus 2. I'm sorry, x squared minus x minus 6 factors to x minus 3 times x plus 2. Then lots of things cancel. The 4's cancel, the x plus 2's cancel. And finally, we'd be left with 1 over x minus 3. All right. So these are all addition problems. The very last operation we're going to look at is subtraction. And you do have to be very, very careful with subtraction because we're going to take the first numerator and subtract every single term in the second numerator. All right, so we have 5 of these, right? So 5 more problems and we'll be done. For the first one, 3x over x squared minus 8x plus 7 minus 3 over x squared minus 8x plus 7. If we subtract those numerators, we have 3x minus 3 over x squared minus 8x plus 7. That one wasn't too bad. We factor the numerator, that's 3 times x minus 1. Factor the denominator, that would be x minus 1 times x minus 7. And then the x minus 1's cancel. So our final answer here would be 3 over x minus 7. All right. Not too bad for the first one. Part B, though, I want you to pay close attention to. We have 3 over x squared minus x plus 3 over x squared. When we subtract these, we have to subtract the entire second numerator. So that's going to be 3 minus, I'm going to use parentheses here, parentheses x plus 3. So we have to subtract that entire numerator. All right. Then what does this become? We have to distribute that subtraction to each term in the second numerator. So this would be 3 minus x minus 3 over x squared. Again, we end up subtracting all of the terms in the second numerator. So instead of 3 minus x plus 3, it's 3 minus x minus 3. 3 minus 3 is 0, so those cancel. So we're left with negative x over x squared. And if we cancel an x from the numerator and denominator, it gives us negative 1 over x. So again, I put a star here to emphasize that for subtracting rational expressions, we have to subtract all of the terms in the second numerator. So be very careful and make sure you distribute this subtraction to each of these terms. So we're going to subtract the x and subtract the 3. On to C. Same idea here. When we subtract, we have to subtract the 4x and subtract the minus 2. Okay? So 5x plus 1 minus 4x minus 2. And again, notice the parentheses I'm using here over x minus 3. This becomes 5x plus 1 minus 4x plus 2. All divided by x minus 3. All right, then simplifying our numerator. 5x minus 4x is just x. 1 plus 2 is 3. So we get x plus 3 over x minus 3. And that's it. Can't simplify that because those are different factors. For part D, x minus 1 over x minus 4 minus 3x minus 9 over x minus 4. That's x minus 1 minus 3x minus 9 in parentheses over x minus 4, which is x minus 1 minus 3x plus 9 over x minus 4. Simplifying the numerator, we have an x minus 3x, so that gives us negative 2x. And negative 1 plus 9 gives us an 8, plus 8. Over x minus 4. All right, from here we want to factor. You need to be very careful with factoring your numerator. We can factor out a negative 2, and that will leave us with x minus 4. So negative 2 times x minus 4 is what our numerator factors to. And for our denominator, it's still just x minus 4. So we cancel our numerators. Cancel out the x minus 4s in the numerator and denominator. And finally, we're just left with a negative 2 as our answer, or negative 2 over 1, which simplifies to negative 2. Last one, 5x plus 8 over 3x plus 15 minus 3x minus 2 over 3x plus 15. That's 5x plus 8. And if we subtract every term in the second numerator, we get minus 3x plus 2 over 3x plus 15. Then combining the like terms in the numerator, 5x minus 3x is 2x, and 8 plus 2 is 10. So we get 2x plus 10 over 3x plus 15. Then factor and simplify. In a numerator, we can factor out a 2. So we get 2x plus 5. And in the denominator, we can factor out a 3. So we get 3 times x plus 5. And then finally, the x plus 5s cancel. And we're left with 2 over 3. All right. That wraps up section 5.3. So the 5 things we should be able to do with rational expressions. 1, if you're given a rational expression, you should be able to factor and simplify it. 2, it's a weird way to count. 2, if you're given, or if you multiply 2 rational expressions, you should be able to factor, cancel out common factors, and then multiply. 3, division. You want to rewrite the divisions by keeping your first expression the same, change the division to multiplication, and then change your second expression to its reciprocal and multiply. So you factor, simplify, and multiply there. And then for addition and subtraction, you add or subtract the numerators, and then factor what you get after you simplify, or add or subtract the numerators, factor the expressions you're left with, cancel out any common factors to simplify.